Alrighty, Mr. Gatekeeper here. Here we have a GK600. This is actually the very first candy painted amp that was ever done. The very first one. Well, let me put it this way. This was the very first case ever painted. And I believe this was the second one that I actually built. But this was the first case ever painted. So anyway, it's been worked on a little bit since then. That was, I think, around 4 years ago or so. And so basically, this fella, Mr. John, he purchased this amplifier and basically wanted me to go through it and kind of change some of the things that people had done and kind of change it back, you know, as close as possible to the way it was when it was first built. And I'll just kind of go through everything that I did do. Taking it from the top here, the fan grill was broke, as you can see. It broke off actually when I removed it. So I went ahead and ordered a new fan grill for you, which is installed right there. Okay. Next, what I went ahead and did was replace the voltage regulator. Back when I did this, I was using some regulators. It was not the best regulator that I probably could have chosen at the time, which I didn't know. I was just kind of using what was being sold to everybody. But we've now got some NTE 966, and I also like using some Motorola regulators that are pretty stout regulators. You can handle some RF around it. So we got all the proper filtering to that. So we've got a regulator on the fan now. If this thing's ever hooked up on an unregulated power supply, it's not going to blow the fan. And also somebody had put 3 resistors on it, 3 100 ohm resistors in parallel, which was slowing the fan down quite a bit. So this thing was not getting a lot of air. Next thing, which is one of the main reasons he sent it to me, he actually sold this amplifier to somebody, and when they got the amp, it wasn't working. It's because of this relay right here. Now this was not the relay that I actually used. I'm going to go ahead and tell everybody right now, right here, right now. If you find a relay that looks like this, with an LED on the back of it like this, 9 times out of 10, it is not a good relay to use, bar none. Which I kind of hate, because I was kind of attracted and drawn towards these relays just because they had LEDs built in them. And what I was doing was changing the LEDs out back then and, you know, making them the same color as the box. Which, you know, that's a pretty cool catch and all, but the problem is you see these little rivets on the contacts right here. Well, they are not contacted to the contact good enough. And what happens is, as this relay becomes to be used, heating, contracting, heating, cooling down, etc., these rivets that's actually on the contacts will begin to move and not make good contact. One of the biggest problems with these relays are, you key up, you unkey, and you don't have receive. You have to key real quick to get your receive back, and the reason why that's happening is your key and the contact is moving a little bit and giving you back to receive. So I actually ordered about 60 of these relays. Okay, as soon as I found out about this, I had like 3 or 4 amps come back pretty quick after I bought these, having this issue. I quit using them immediately. But somebody replaced the relay I had in there originally with this one. So that's what happened with that. The person probably just wasn't aware of it. We have some real good relays now that cost the same as these that we use, that are work very well. Next thing I did is, whenever someone removed that relay, I had the preamp mounted on top of the relay. It was a 3-pole double throw relay. I had the preamp mounted on top of it. It looks like when they removed the relay, they just removed the preamp as well. And from what I'm guessing, they may not have completely understood what the preamp was doing with the invert circuit, and they installed another preamp. Okay, and when they installed the other preamp, they didn't wire up the preamp switch correctly to the power switch so that the preamp only gets power when the amp is on. See, with the preamps that I normally put in amplifiers, as you can see right here, they have an invert circuit built onto the preamp, and what that does is that allows you to turn the preamp on with the amp still turned off, and then when you key your microphone, it disengages the relay so that the RF flows through the relay bypassing the preamp. So it allows you to use the preamp with the amplifier turned off, which, you know, you'll see Texas Stars that does that, but they're not using a circuit. That's just the way they have their switches wired. They're able to do that. And you'll see some other amps out there that have that option too. So what happened is what I'm pretty much guessing is somebody attempted to turn the preamp on with the box off, and they fried that preamp. So it looks like when it got here, somebody had just cut the wires. So it looks like that's what happened with that. So I've got the original style preamp back on there with the invert circuit. Okay, so that's all good to go there. Let's see, I went ahead and added the filter cap on this thing too, man. This is actually a big whopping 8200 microfarad cap, and it, you know, had some good space right here. I probably should have put one on there when I built the amp, but I didn't. So I went ahead and added a little filter cap there just to help with the DC filter on the hot bus. These right here are actually 0.2s. So this right here, these two caps and these two caps down here are equivalent to 8.1s, 8104 caps. I'm actually out of these bad boys now. I bought like, I think 500 of them, and I'm finally used my last couple of ones. I love them caps. You can use less of them and have more filtering power, filtering towards the higher frequency aspect of whatsoever's on the DC line. So anyway, another thing is, which this was actually an error on my part, and I remember it now. I had forgot completely about this. Back at this point, I purchased this board for this box separately, okay, and for some odd reason, when I got the board, I didn't even notice until I pretty much, let me put it this way, I made an honest mistake. Instead of putting the board inside the case just to make sure it fits right, which you wouldn't really think you would need to do that because these boards are supposed to be made for these enclosures, I started building the amp on the board without ever putting it in the case. And because I think the actual case was being painted or something, I can't quite remember, but pretty much I had majority of the amp built. I go to put the board in the case and notice that it doesn't match up to the holes. It actually did not match up to the holes good. So I had to emphasize, you know the word I'm trying to say, emphasize at the time, and just make it work the best I could. And you know, I made it work. But like I said, you learn more as you go on. You pick up more little stuff as you go on doing these things. And one of the big things I've learned when you're dealing with devices that make heat, you want that air to flow through that heat sink and not be wasted. So what I went ahead and done for you is, one of the problems was with making this fit and everything, there was a gap in the very back that was taking a lot of your air from this fan and just taking it right here in the back and out the back of the amp, not even cooling the heat sink. And that's just wasted air. I'm glad that it hadn't run hot on you and all that good stuff, but now you're going to have forced air. There's no air going to be leaking out the back here. About the best way I really could get that done for you, man, is just like I already talked to you on the phone, just get back here with some clear silicone. I had to do this a good bit with some Dave made style cases and stuff. I like to make them airtight on the back. So I just got back here with some silicone, as you can see, and made it airtight. Yeah, it may not be the prettiest thing in the world, but the thing about it is it's airtight now, and you're not going to have any air being wasted, just flowing straight out the back, not even hitting the heat sink. So now all the air is going to be forced down here in the front through the heat sink out the back. So I went ahead and did that for you. Another thing I went ahead and did is as you can see, I put the new preamp on there, putting a new relay on there. I went ahead and wired it up the same way that the last one was wired up. This actually is a pretty good way to do this. Taking the case off, taking the wires straight into the SO239s. This right here takes away a little bit of length from the that the RF has to flow through to hit the relay, which I've kind of started growing accustomed to like doing the relays this way. Sometimes I'll actually cut the case on the bigger relays to keep the case on. But let's see here, and I went ahead and added the SSB delay switch back on. Somebody had removed this and just left the hole there, so I went ahead and put you an SSB delay switch back on here. And of course, this ain't the best amplifier to use on sideband. You know, it's a 6-pill Class C amplifier. But if you wanted to play around on sideband with it up on channel 38, etc., have fun, man. Hey, I've heard certain people say, and this one particular person, this is probably the only thing I can really think about that I disagree with. He says you can fry your amplifiers, Class C amplifiers, run them on sideband. Well, the problem what I have with that is I have ran amplifiers on sideband in Class C with a delay multitudes of times, years. There was one point I ran a 4-transistor amplifier in my mobile and ran hardcore freeband, sideband for like 2-3 years. Hardcore every day. Never caused an issue at all. You know, it's just not going to be linear. It's not going to be 100% replication of your original signal. But heck, when you're playing around with 38 lower sideband and stuff like that, ain't nobody going to know the difference if your radio's clean. I'm just being real with you. But if you're going to take this thing up on the free band or try to go up on 10 meters, you need to be biased. You need to be biased. Hey, I'm just trying to keep it real with you. That's all I'm trying to do. But I have never witnessed an amplifier or transistors blowing from using them on sideband with them being Class C bias, zero bias. I myself have never witnessed it. Now, I'm completely open for possibilities of that's how you learn. I'm not saying I know everything, and I'm nowhere near it. And all I can say is with my own experience, I have done that. I know many people that's ran Class C amps on sideband has never had an issue. So that is what that is. But I am a big fan of biasing. Don't get me wrong, but it's all about what type of operator you are. If you're just going to run this thing on AM, heck, it's completely fine the way it is. And you can run a little bit on sideband on, 38, 39, 40. Just play around with it. See what kind of results. Ask people how it sounds, etc. Okay, let's see here. What else do we do here? I think we're about getting close. Well, they had these big 5-watt resistors on here, which I understand why they had that on for the telltale balancing resistors right here. I'm sitting here looking through the viewfinder, just pointing, not knowing where I'm. There we go. And I know why they had them on here, because this box had some imbalance issues due to mixed ferrite on the output combiner, etc. That it was just a complete mistake on my part way back then. I bought a big bulk of ferrite from a particular place I'm not going to name, and the ferrite was mixed. And at that time I was actually making my own combiners and splitters myself, putting them together, making them myself. And I didn't understand at the time. You know, you need to check them. If you ever buy a big thing of beads like that, it don't matter where you get them, you need to check them, bar none. So ever since then, that was a valuable lesson. Super valuable lesson. Because now I match my transformers. I even match my ferrite beads I'm using for my chokes to ground. I mean, I get kind of crazy with it, but I'm just OCD when it comes to matching things. Makes me feel better. So it was a big lesson learner about 4 years ago about the ferrite. You know, so that's what was causing the issue with it. And God bless Mr. Stickman, he helped me figure it out. we sent this over to Stickman, and he pointed out pretty quick, hey man, you got some mixed ferrite in here, man. And I think lo and behold, I think I made the output transformers too, and there was like one output transformer that had 1 or 2 of ferrite in it that was not 61, even though it looked like 61. I think it was 67 or something like that. So he pretty much had to just go ahead and change out all the transformers and the input and out the splitter and the combiner. And I learned my lesson there for sure. I ain't scared to admit that, man, because that was a big lesson learned there. So anyway, I think that's why they had them big 5 waters on there. So I went ahead and took that off, man, put some smaller resistors in there. If you ever have a problem with this amp, you want these resistors to go up quick. You want them to go off quick and smoke. You want them to smoke because you want them to let you know there's a problem so you'll get off the key. Now, if this amp was built a little different, using some hybrid style coupling methods and stuff like that, you know, we could put as a 2-to-1 transformer after this right here and tune out each of these 2 transistor amps and put a balancing resistor out there to where if a 2-pill section goes out, the other 2 will be working. But of course, it's a lot more work. You got to have you a big resistor too to be able to handle at least 25% of that mismatch of your total output. So you see that more in other type of amplifiers and stuff. But anyway, let's quit with all this talking. I'm wasting a lot of time here, ain't I? I'm a big talker. I think I pretty much covered everything. Let me take another gander through here. I fixed a couple of cold solder joints. There was one of the feedback circuits that was actually completely unsoldered on the back end. It was just literally hanging. I fixed that and just went through and touched up a couple of places that I saw that could handle a little bit more solder. Somebody has blown a transistor in this box before and replaced the transistor. I kind of touched that up a little bit, just touch the solder and work on it a little bit. Oh, and the next thing, I almost forgot. I really don't know why somebody would have wanted to do this, but maybe it was just a preference. Somebody cut the resistor right here on this switch going to ground so that the LED wouldn't light up when you push this in. I have absolute no idea why they done that, or unless it was just a preference, they just didn't want to see it being lit up, which I don't know why. It's not real bright. Let me turn this on. You see, it's not real bright at all. So I don't know why they wouldn't have wanted that, but they didn't, so looks like they just cut it. That's your fan working now. Pushing a lot more air than it was. Alrighty. And here's your invert circuit right here. Like I said, box is turned off, okay? I'm going to turn the preamp on. Alright. Alright, see, the preamp is on now. Preamp's working, etc. It's on a dummy low, but it's working. Alright, when I key the microphone, it's going to bypass that preamp. See? 1 watt dead key. Getting close to about 4 watts. So, you can hear it keying up and disengaging, and it's also set up to where it would work on sideband if you were on sideband using it. So that is that. And that's your SSB delay switch in the back right there. And we just got it hooked on the little servo supply right now. I'm gonna have to hook a driver up, and that's another thing. I've missed out a lot of work, a good bit of work this winter, and I finally figured out why after doing this modification over here. About a year ago, part of my ceiling up here fell. A lot of you know me personally probably know about that, which is quite dang embarrassing, but it's due to whoever built this house did not quite put the ceiling up the way they should have, and moisture was getting up there, and it just fell through the nails and fell down on me. Well, I don't know why I didn't put two and two together this winter, but that's why I've had a lot of issues coming out here and getting work done this winter, being too cold. It's because all the hot air from the heaters is just escaping out the top. But anyway, a good buddy of mine, the guy that paints my boxes, a real good buddy of mine, had been telling me, let's put up some curtain walls around your workspace. Well, that's what we got now. I'm sitting here in what I like to call now my plastic man cave. So I am completely sitting in a plastic box, and I only need one heater, and it is about 22 degrees hotter right here than out here in the garage. God, that air's cold. It's amazing how hot it is in here now. And I have lost a little bit of hand space. Girl, get off that table. You know better. And that's another problem I'm starting to have now. She wants to get up on these tables since she don't have as much room to move around in here. She wants to be in here with me, but she don't want to follow the rules. So we're going to figure out something to do about that. But for now, I'll let her be. So yeah. So I've got me a little box here where I can now not lose work time and get a little bit more organized, since I'm pushed against the wall here, and I got me some shelves up here now so I can put my bird meters up there and mount my radios. And I'm still going, I got my bench radio still up under the table. I'll just leave that up under there for now. So I've still got some more work I need to do to help things get a little bit more organized to where I can kind of have everything I need in one spot. A lot of y'all may know how that is. So I need to hook the driver up, but just on the servo supply. That's the 500 watt slug. Go in the corner. And that is peak. And that's on 14.5 volts. So let me get this driver hooked up and we'll show it to you working, man. We'll be right back. All right, brother. I have my bench 2-pill, just two 1446s. It's going to be driving this 6-pill with about 100 watts, 100 bird. Okay. I've got the 100 amp unregulated supply on the high tap, so it's going to pull this supply down beyond its duty cycle. Okay, meaning the amp's a little too big for this 100 amp supply. It really needs to be on about a 120 or a 150. But this is just to give you a good idea that it's working and doing what it's supposed to be doing. Okay. So like I said, we're going to be putting about 100 bird into it. We got the 1000 watt slug. This is RMS. Here's what we're getting out. Go. Look at that. 600 bird right dead nuts on. Go. Beautiful. Just a hair under 600. That's 100 watts per transistor. 100 watts in, and you're getting 100 watts per transistor. That is a really, really good factor there. So she is working great. The voltage is dropping to like 13 point something volts too. Yeah, 13.1 volts. So you're getting 600, pretty much right there at 600 bird already, just at 13 volts, man. I'll tell you, man, these ported 6-pills are some bad mamma jammas. Here, let me go ahead and show you what it's doing on the peak. So I need to get me another bird meter up here so I can show the peak and the RMS at the same time. That's the only reason I hadn't been able to do that before now, because I hadn't had a room. But now I got room, so I'm going to do it. Alright, give me a second. I'll put that down and put me a 2500 watt slug in so you can take a look at the peak watts, which you may be a little bit more interested in seeing, John. Alright. PP. Reading 2500 watt slug, so we're looking at the top scale. Okay, where you see the 10, that's 100, the 5 is 500. Oh, that is beautiful. That is absolutely beautiful. That is 1750 watts PEP. Oh, we're letting the mop fly. Break. Beautiful. Absolutely beautiful. I love seeing these 6-pills work, man. Goodness, that's awesome. So that is 1,750 watts on 13 volts. We are driving it pretty decent, okay? I am driving it pretty decent. Just to show you. Let's see, let's turn the amp off. Well, that's why I need 2 bird meters. I had to put a smaller slug in. Hold on a second. I should have showed this beforehand. Can I do this with one hand? No, I can't. Hold on a second. Put the 500 watt back in. Alright, this is just the 2-pill 1446 box. Middle scale. Oh, yeah, a little bit over 250 watts peak drive. And if you look at the RMS, right there at about 100 bird, like I said. So I'm driving it right there about 100 watts. And like I said, this is driving it a little strong. You pretty much can get this same output of this box on 15 volts, 14.5, 15 volts, with probably about 60, 70 watts bird drive with about 200 watts. If I was you, try to keep the drive around 150. You know, PEP, if you absolutely have to go to 200, that's cool, but you just run this box easy, man. Let it give you about 1,200 watts peak. If you just absolutely have to push it up to 1,500, I understand. But if you just ran this joker like at 1,200 watts peak, like 500 bird, 450 bird, man, this thing will last you forever. So there you go, Mr. John. I got to go ahead and get on the next one. I have 28, I think, Texas Star 500s and 667s that I have got to get out of here. Alright, bud, I hope this thing lasts you. I think you decided not to sell it now. So I hope you enjoy, my friend. 73s to you. And just to give you an idea before I go, if I had a 1-pill hooked up, which I probably should, I'm going to get everything over here set up where I can have my 1-pill and my 2-pill all mounted and all that good stuff, so I don't have to do all this moving around. If I had my 1-pill hooked up, it'd probably be on 13 volts like that. It'd probably be doing somewhere around 500 bird probably, and would probably be somewhere around 1,400 peak. That's just a guess, because the 1-pill will be giving it about 40, 50 bird drive, and about 110 watts peak. And you know the cool thing about this, man, I never even hooked up the hot radio. So I can hook the hot radio up right here, which I don't have completely all wired up yet. I got to hook the power wires up to it, or hook the power wires up to the power supply. If I hook that up to it, this thing will be doing 1,000 watts bird in the corner. No problem. All right, man. We'll see you. Bye-bye.